Okay, now I will talk about the next example, which is spring system but vertically. You can see one like this example in the book, this one. Now, suppose that we have a spring with a mass vertically. If the spring is compressed in the first situation with height half meter, then in the second position it released the mass at height 0.7 meters. The spring constant is 2000 newton per second and this mass is 2 kilograms. We need to choose a zero level, a reference for our solution. The most we can choose this level, we can use this level, we can use this level, but I think you always, when you choose this level, when the compression for the spring is zero and it is free, and there's, when you choose also this is a zero level, then the potential energy here will be zero. Then you will have just the kinetic energy. We will see that now in the example. We need to know also that the mechanical energy is equal always to kinetic energy plus potential energy. But in this case, we have two potential energies. One, due gravity, the second, due the spring force. So our mechanical energy is equal to three terms, not just two. The kinetic energy is always always the kinetic energy, half mv squared. But the potential, it will have many forms. We here in this course we will deal just with these two potential energies. In general, we have electrical potential energy, we have magnetic potential energy, we have nuclear, we have many forms of the potential energy. Okay, now we need to assume our reference point or height. We assume it this point at the releasing, at point number 2. Okay, and also we need to know the spring compression at that point. It should be zero at this point, the spring compression. Okay, so at point 2 the compression will be zero, and the distance for compression between 2 and 1, the compression, this value, it's the difference between the altitude of 0.7 meters and 0.5. When we compress this spring, it will come from 0.7 to 0.5. So the compression will be 0.2 meters, which is 20 centimeters. Okay, now to start solving now, as we said, we need to know, we understand now the question. We need to know now for the first part, for point number 1, we need to know the numerical values. The mass is 2 kilograms, spring constant is 2000, the compression is 0.2 meters, the velocity for this body now it is 0 because it is stationary, the altitude h with respect to our zero level, it is a negative value. It is minus 0.2, minus 20 centimeters. So the altitude is negative value. Our potential may have negative values. It's okay. Now, the mechanical energy for our system is equal to kinetic energy plus the potential energy due to gravity at point number 1. This is at point number 2. I put it here to find the altitude, the difference between the two situations, and the potential energy due spring force. Okay, the kinetic energy is half mv squared plus mgh at that point, which is minus 0.2, plus half kx1. Okay, the velocity is 0, so this term will be 0. M is 2 kilograms, G is G, H is negative 0.2, yes, plus half K, which is 2000, and the compression the distance, which is 0.2, 20 centimeters, 0.2 squared. So my mechanical energy now is equal to 0, negative 3.92 plus 40. This is 40 and this is negative 3 point. So the total mechanical energy for this system is 37.08 joules, which is constant between any two situations. Okay, now we will go to the second point. This, when the spring released the mass, at this point the altitude, it is h2 minus h2 because it is the zero level, so the altitude here is 0. So my variables or my numerical values, the mass is still 2 kilograms, the spring constant is the same, the compression distance is 0, now the spring is free. The velocity, we don't know the velocity, we'll compute the velocity, and the altitude or the height is 0 because it is at the 0 level. Okay, we will use the same equation, the same formula for mechanical energy, the kinetic energy, the potential energy, this potential energy to the spring. We put the numerical values, the velocity is unknown, and the potential energy is h at that point is 0, and the compression distance or displacement for the spring is also 0. So these two terms are zeros, 0 with 0. And we have also here the kinetic energy. In this case, our kinetic energy is equal to mechanical energy because this term is 0 and this term is 0. Our mechanical energy is 37.08. So kinetic energy is equal to mechanical energy at any point, it is constant, which is equal to 37.08 joules. But what if we need to compute the velocity? The velocity, half multiplied by 2 multiplied by v squared. I can cancel these tools with each other, and then v squared is equal to the numerical value of the energy. So v2 squared, the releasing the velocity, is equal to 37.02. The velocity is the root value for it, which is approximately 6.1 meters per second. This is the velocity that the body will leave the spring system at that point, and the kinetic energy is also at that point is equal to the total mechanical energy. So you need now to be sure that we have 3 terms, 2 of them are potential energies. It is simple. If you divide the problem to the small pieces, it is easy to be solved. You will find these sheets, also the video on Canvas. Thank you.